Hey there, Math 126 students. So in this video, I'd like to just do a collection of old final exam questions that have to do with chapters 12 and 13. That would be vector facts, knowing your projections, knowing how to find the angle between two curves, knowing how to find the equation of a line. That's a big topic. How to find the equation of a plane, how to name a few basic surfaces, and then the various calculations we did, tangent lines, curvature. To me, that's more about knowing the formulas and how to use them. But let's go through and do a collection of those sorts of problems. Okay, so what I've done is I have a few old exams. I think I'll just try to briefly I'll look for those questions on that type. I haven't really prepared this. I'm just trying this. So let's start with the winter 2022 final. And let's just look at the first page. Okay, so again, I haven't prepared this at all. I just want to give you a fresh look. Some quarters, I'm not as keen on these, but some instructors like having multiple choice. When I get a multiple choice question like this, there's two thoughts in my head. One is this a known fact? Like, can I directly compute it? Well, then I'm done. Is there an obvious, what we would call in math, counterexample? So if I don't immediately recognize it's a known fact, I would then try to think of a small example. And then third, we could spend a little longer. Can we actually compute it or something? Okay, so what's bad about these is a little open-ended. It may not be obvious how to get to the answer, and you may have to kind of come back. There's usually like one that's harder than others. Each thing's not worth a lot, but anyways. So when I look at this one, it mentions the magnitude of the cross product. It mentions the dot product, then the angle between. So you sort of go, what's going on? Also, you want to make sure you're not missing any known facts here. Now the fact that, so anyways, this is where I would go to my note sheet. So this is me thinking about, are there any known facts? Yes, there are. This is the magnitude of A, this is the magnitude of B, this is sine of theta. Are there any known facts about the dot product? Yes, there are. A, magnitude of A, magnitude of B, cosine of theta. So those are my first things. Again, I don't know what's going to happen. Is between. The other thing you actually could do, this is the longer way if I get stuck, is you could just do some examples. Meaning you could take two vectors where the angle is 90 degrees and see if this is true. Like 1, 0 and 0, 1. This is what I mean by that would be like the longer way to go, but that's what I would do if I was completely stuck. Okay, so those are, like I said, it's not, this one's tougher than some of the other ones on this page because it's kind of open-ended. But if you do the dot product of these two, this is just me experimenting. You get 0. So it can't be 90 degrees. So there you go. Can't be, it's greater than 0, so they can't be perpendicular. My other thought is the dot product is positive when the angle is acute, and the dot product is negative when it's obtuse. So now's when I'm starting to kind of go between. Even just running that example helped me because I was like, oh yeah, 90 degrees makes it 0. Basically, they're saying it has to be negative, so it has to be an obtuse angle. Okay, so surprisingly, there's more information in there than I thought. I could have done more experimentation, but this alone tells me that it's an obtuse angle between them. Okay, so that means it's bigger than 90 degrees. So now I've kind of hammered out a few things. Okay, so then I'm down to two things. Then you just flip a coin. Hope you get lucky. No, that would be good. But you could run an example. Like, you could just pick 120 degrees. Pick two. You might say, well, how do I find two vectors that have 120 degrees between them? I think you could do it. Here's the vector 1, 0. you need something where it's 120 degrees, so it's 90 plus 30 degrees. I think you could figure that out. If you had your unit circle, you would definitely have it. Okay, the cross product is bigger than the dot product. So what can I say about that? So if I have this, and you can see I don't have a direct path. I'm sure I'm missing a simple idea. I'm just trying to say, what could you do if you were completely stuck? So what I just did was replaced. I replaced this with this. I replaced this with this. Threw in that negative. Okay, cancel, cancel, cancel. This means that sine of theta is greater than negative cosine of theta. What's bad about these is you're like, I'm only on problem 1a and I've spent forever. That's why I don't like them. But you could save that page for later. Most things will be faster. So you basically need to know, when is sine greater than negative cosine, and when is that greater than 0? Now it's a lot easier to test. And you might say, well, I don't know how to plug in those numbers. Well, maybe you just plug in 180. What happens when you plug in 180? So if you plug in pi and pi, this is 0. This is 1. Okay, there's kind of a problem there. When I plug in 90 degrees, pi over 2, I get, what do I get? 0, 0, 1. So 90 degrees works, 180 degrees doesn't work. That already gets me thinking here. If I was doing this myself, I would then do like 120 degrees. You could even go further and divide. We want to know when sine over cosine, which is tangent, is greater than negative 1. So I'm starting to think that is it. But I would run another example on my calculator if I was a student. But there's some thought process. So that's how I thought through. What are the known facts? These. Could I do some quick examples? All right. So let's go to the next one. Suppose that the projection of B onto A is 1, negative 1, 1. Then B could be what? So here's an example where we could do the following. It doesn't tell you what A is, but you could say a little bit. You could write down the formula. That's kind of the long way, but let's do it anyways. B dot A over the magnitude of A dot A. So that's that formula. It's not that informative, but they are telling you this is equal to 1, negative 1, 1, which means A is in the direction, or is parallel. I bet students were probably panicked. You know, these first two parts. That's I don't love this on the first page of the test. But you kind of have to buckle down and say, okay, if I want to get 100%, I'm going to have to maybe come back and work on a couple of these parts, run some experiments, see what happens. But ultimately, when you're projecting, this is a small thing, but when you're projecting onto the vector 1, 0 or the vector 10, 0, it doesn't actually change your answer. So the funny thing about these questions is if you could actually, if you don't know what A is, you can just use this in place of A because it does not change the projection. So the direct computation, there is a direct way to do this problem, which is to just plug it in. Not elegant. I don't know if there's another reason I should know this answer, but let's just start doing it. So I'd like to do B dot 1, negative 1, 1 over the magnitude of A. So if I'm using that, it's the square root of 1 squared, so square root of 3. 1 plus 1 plus 1. This is the projection vector. Okay, so the question is, how can that be that? Well, that would only happen if whatever, and this is, another bit of advice is to label this B1, B2. We're getting kind of bogged down here. I didn't intend this, but I know that people always ask about this, so I'll move forward and I'll add some timestamps in the video. But this over the square root of 3 has to be 1. So then I would just test them. If I do 2, negative 2, 2, does that work? No. If I do 1, if I do negative 1, oops, this is not square root of 3. This is square root of 3 squared. I just miswrote the formula. So I need b1 minus b2 plus b3 over 3 equals 1. So I basically need these numbers to be 3. So I should check that again. 2 did not work, no. So then if I did negative 1, 1, negative 1, nope, that doesn't work. If I do 2, 2, 2, that's going to be 4 over 3. That doesn't work. What about if it's 2, 3, 4? Yep, that works. That's the only one. All right, those weren't great, but the intersection of the paraboloid and the xy planes, this is more of a visual. This is about knowing this name. This is a much shorter question. So this comes down to a known fact. Don't really need to do any examples. This is positive right here. So the traces are hyperbola, hyperbola, and this is a hyperboloid of one sheet, because when z is gone, you actually do get a circle. So there are two ways to answer this question, knowing the name or just replacing that with the z. That's a circle. Done. So some are faster, and this kind of is true. When you go into a page like this, you go, there's going to be a couple that take me a while. There's going to be some that are faster. The surface has a local maximum at this. This is actually a short one, too. So it's just bad that the first two were so bad. But you don't even need to calculate. So if you plug in a 1, 1, 1, 1 works in here, so it is a critical point. 1, negative 1 works, negative 1 works. Okay, all those points work. So now we're switching to the second thing, which is how can we tell if something's a local maximum? Well, now we got to compute the second derivatives. This is 6y. Xy is 0. So we're looking for the one where d is positive, and d would be 36xy minus 0 squared. We need this to be positive, and we need these, we need to be local maximums, concave down. We need those to be negative. Both of them. So which of those numbers make both of these negative? Only this one. Done. A lamina, okay, this is a center of mass question, so we won't ask it. So that took a little while, but there's an example of a multiple choice true false and how I think through them. And I hope that at least gives you a perspective of, most of, I would say half of them at least will be fast. The other ones you might have to do some examples or write down known facts. Okay, so then we have an actual curve question. So now we can pick up the pace a little bit. It says find the tangent line x, y, z plus, 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 t, t, t. Actually, I would advise you to use something else, but I give you full credit. 0, 0, 0. Okay, we need r of 0, which is 1, 1, 0, 1, 1, 0. We need r prime of t, which is 2t, negative sine of t plus 4 and 3, and r prime of 0 is 0, 4, 3, 0, 4, 3. We want that to be fast. Find the unit tangent vector to the space curve at 0. So I think I'm not going to compute that. I don't know if that's a good use of our time. I guess it's so fast, I might as well compute it. Unit tangent vector 0, 4, 3 divided by the square root of 0 plus 16 plus 9. Oh, it ends up being 0, 4 fifths, 3 fifths. Find the curvature. All right, I'm not going to do that part. Okay, maybe we'll do one of these implicit. So it says find the derivative with respect to x. So your two variables are x and z right here and right here and right here. So we start differentiating. Because there's two variables here, you do need the product rule. So derivative of the first times the second. So derivative of the first is 1. It's just going to be times the second. There's the derivative of the first, 1 times the second, plus the first times derivative of the second, which is negative sine of z times derivative of the inside, which is dz dx. Plus, there's a y squared. In this case, it's a constant, so that's just a coefficient. dz dx. Minus 2x e to the y plus 0 equals dz dx. Oh, and it asks for the general formula. So it's asking for the general formula. You got to get all the dz dx's on the same side. So you say cosine of z minus 2x e to the y is dz dx 1, this is 1, plus x sine of z minus y squared. And then divide and you got it. Find all intersections of this with the x-axis. If you're on the x-axis, then two of your components are 0. So it's saying when is yz 0? All right, let's look. Where are the line and plane questions? Let's go to spring 2007. Back then we used to ask the Taylor series first. Okay, find parametric equations for the line of intersection of the two planes. We're trying to find the equation of a line. The strategy is we need to find a point and a direction. If you're finding the intersection of two planes, my strategy was to find 2 points. Now this is kind of an interesting example, I think, because if you subtract the two equations side by side, the y and z cancel, which sometimes throws people off. You know, if I did this equation minus this equation, just to do a quick combination, I get x has to be -1. That sometimes throws people off, but actually that makes things nicer because that means every single point on the intersection has to have x is -1. And so if I'm trying to find 2 points, it's made it a little easier. So now if I go back here and I plug in a -1, the conclusion would be that -2 y to my plus z is 1. This is sort of stuff that I think instructors do this to try to make the problem easier, and in doing so they make it harder. I like to say no good deed goes unpunished. That's one of these. Okay, so here we go. That's what happens. Both of these lead to this. So I just need to find numbers where that's true. If I was trying to find such numbers, I would do 3, 0. And then I would do probably -3, 0. And then I'm done. Pick one of your points. It doesn't matter which one. Do 3 subtractions. That minus that is 0. That minus that is -3. That minus that is -3. Done. So it can be short, but find the equation of the plane that contains the line we just found and this point. So when you're trying to find the equation of a plane, if you remember, you need a point and a normal. So you're trying to fill in this. They told you a point, so the only remaining question is, can I find a normal vector? Here, here. How do we find a normal vector? We try to find 2 vectors that are on the plane and do their cross product. Now in this case, I already have 2 points that are on this line, and they tell me the line is contained, so I have 3 points already. So if I was doing this, I would just take what I've already done. I would do PQ and PR. The order doesn't really matter, but let's do it. So I would do PQ, which I've already done, is 0, -3, -3. And then I would do PR. So 1 minus 1 is 2. 1 is 1. -1 minus 3, -4. I would take their cross product and I'm done. So take the cross product of these 3 things. And then whatever you get, boom, boom, boom. Okay, I think that's enough. I could... This I've already got too long, but the overview there is we did now kind of a collection of examples that have to do with curves, finding them, tangent lines, finding lines and planes. I hope that's sort of helpful.